in this problem, we have to find right intervals. So first of all, what is an interval? So an interval is a tuple. So first component is the start time and the second is end time. So this is one interval. And in this problem, you will be given a list of intervals. So each interval has two things, A1, A2, B1, B2. So these are all intervals and you will have many such intervals. And these are not sorted by any means. Only thing is that A1 is less than A2 or B1 is less than B2 since the start time has to be less than end time. So this is what it is given, and these intervals among themselves are not sorted. And there is a meaning of a right interval. So let's pick this interval B1, B2. Then all the intervals whose start time is more than B2, end time of this. So that means there is a one task which starts and ends at some time, and whatever tasks will start after this, those are called right intervals. So there will be many such intervals and we have to find the index of minimum such interval. So there will be multiple intervals which will start after this, but one of them will have the minimum start time among these. All these start times will be more than the end time of this, but the minimum among those. And this can be even equal, so more than or equal to the end time of this. So let's look at an example, then it will be more clear. So let's say we have this input, this is input, and it has three intervals in them, and these are not sorted, but within the interval, start is always less than end. So for 1, 4, the end time is 4. So what intervals start after this, or at least at 4 or later? None of them. This starts at 2, this starts at 3. So both of them are less than 4. So for this interval, there is no right interval. So -1 denotes no right interval. And these are actually denoting the indices. So here we are concerned about indices of intervals in the original list. So this list has three intervals. So this is at index 0, this is at index 1, this is at index 2. So for this interval, we did not find any right interval. So it's -1. For 2, 3, it ends at 3. So what intervals start after 3? So it's this one. It starts at 3. So we can include this equal to or more. So there is just one of them. So minimum is just this one. If we had, let's say, 5, 6 also, then we had two right intervals. This is also right interval. This is also right interval for this interval. But we will pick the minimum, the interval which is at minimum start time. So its index is 2. We had 0, 1, 2. So we put 2 here. Next is 3, 4. It also ends at 4, and there is no interval which starts on time 4 or after time 4. This starts at 1, this starts at 2. So again, it's -1. So if there is no right interval, put -1. Else, the index of the right interval which starts earliest. So what we can do here, one naive way would be to iterate through this list. That is n iterations if there are n intervals. And for each interval, we know the end time. So we go through each interval and check what is the minimum start time which is more than or equal to 4. So for each, it will take, for the first one, it will take n-1 comparisons. Second one, n-2 comparisons. Or in fact, these are not sorted. So every time we will have n-1 comparisons. We have to compare with everything. So in total, we have n times n multiplied by n-1, that is n square. So that algorithm will work, but it will be O of n square. And space will be O of n. We have to return this list. But if you don't count this list, since this you have to return anyway, there is no escaping this. So any extra space you can think of O of 1. But if you count this space, then it's O of n. So this is the naive way. So can we do better? And yes, you may have guessed that immediate solution that comes to your mind is, what if we sort these intervals based on their start times? So after sorting, we will get 1, 4, 2, 3. In fact, in this case, they were already sorted, but it may not be the case in other examples. Now we know that we are only concerned about intervals which are more than 4. So we will look in this side. Since all the intervals, since the end time is more than start time, So all the intervals which are before this, their start time is less than its start time. So how can their start time be more than this end time? There is no way. So we will only look in this part. And these are also sorted. So whatever will be the first value which is more than 4, we will pick that. But here also, if you don't utilize the sorting thing properly, it will take n square. So here we can do binary search since these are sorted and we are looking for the smallest first value which is more than 4. So we can do it in log n time using binary search. Next, for this one, it will again take log n minus 1, then log n minus 2, and so on. So overall it will be log of n multiplied by n minus 1 multiplied by n minus 2, that is, it will be less than n raised to the power n, which is n log n. And even the sorting had taken n log n time. So total time also remains n log n. So this is some improvement O of n log n. I cannot think of any O1 solution in this case. And space again it will be O of n. And in this case, we even need to use extra O in space. So this we have to return anyway. But once we sort, their original ordering is lost. We lose their original indices. So this was at index 0, 1, 2. Maybe after sorting, this comes first. So we lose track of the original indices. So what we do, we create one intervals. So we have one interval, let's say AB, followed by its index. This was originally at index I, and a list of, so interval now is increased. So this is also denoting one interval now, which stores the actual interval and its index. So this is another bigger list, or you can call it pair also, since it will have two values, one the actual interval and the one its index. And we will have a list of such lists. And we will sort these, and now we have the track of their indices. So let's write the code for this, and we will write it in C++, Java, and Python. So you can go through this example. I have covered pretty much everything. So first we need to store this in this form before sorting, so that we keep track of the index. So this is just one extra thing that is added to the interval. You can also, there is another way that instead of interval, you create a list where copy the first two elements of interval and the index. So this entire thing will converge into one list, but let's keep it separate. So it's vector of pair. So you can also take it vector, and in fact they have taken the intervals as vector, although we know that this will always have two elements, so we can take it as pair, and that may be slightly more performant than taking it as vector. You can convert these pairs to vector and see if there is any time difference. So pair of int, so this is the actual interval, and the outer one has the index, which is also int. So this pair ends here, and this is a vector of such pairs. And this we can call sorted, since this we will sort. N is the number of intervals. So if you are using vector here, vector of int instead of pair, then you can directly use intervals I. But here I have made it pair to be more explicit. So we will have intervals I0 and intervals I1. So this is the inner pair, and then the index. Index is I itself. And that's it. So we have inserted everything to this new vector sorted. Then we will sort it. So by default, if we don't specify custom comparator here, it will sort on the basis of first interval and which is the desired one. So now it's sorted. Now what we will do, we have to return the result, which is a vector of int. Let's call it result, and we know its size beforehand, so why not initialize it. And the default index is -1 if we don't find it. Otherwise we have to do binary search. So we need to define a function for binary search. Let's call it binary search itself, and we need to pass the sorted, this array, this vector, and current intervals I 1. So we will pass the second end time. So we have to find all the intervals whose start time is less than this end time, and we will pick the minimum of that. Now is the time to define binary search. So finally we will return the result. Now let's define the binary search. So first parameter is this sorted, which is of type this thing. And the second is integer. And here make sure to pass by reference in order to avoid unnecessary copying. And then if sorted n-1 dot first is less than x, then there is no point in searching. Even the first one of the largest interval, the interval that starts last, is less than x, then all the others will be less. So straight away return -1, else do the binary search, l equal to 0, r equal to n-1. While l is less than equal to r, mid equal to l plus r minus l divided by 2. First dot first is the start time, is more than right is mid -1. So I hope it's clear here. Here the first means pick the interval. So this outer pair has interval and its index. So this first means pick the interval and not the index. And then this first means the start time of that interval. So if the start time of mid is more, then we look in left part, but there may be a case where the mid was itself the right interval, the minimum right interval for this. In that case, this loop will end when L is more than R. In that case, L will be one more than this right, and we will return L in any case. So that should work. So we are taking L. So when L and R cross each other, then L will be pointing to the actual right interval. Sorry, it should be second. Second is the index. And let's see. So this was a small example. Let's try on this one. And it works, so let's submit. And the solution is accepted. and it takes 132 milliseconds. That is, we are right here in the top, and there is a huge variation here, and it's good that we are around 99% mark. Next we will do it in Java. So binary search I will straight away copy. Let's stick to this convention, pair. And this is a list, so it should be get n-1. And first is in the pair, the first one is the key and the second is the value. So the way to get the first one is get key, and again get key, and if you want the second, you do get value. Here it's second, so get value. So this binary search part is done. Next is this one. And here this will fail due to we need to provide a custom comparator here. So these are pairs of pairs and int. So let's define it. So it will be a dot get key. So we got the interval from this. So this a holds one interval and one index. So get key fetched us the interval, and then we want the first start time of that. So again get key. So this is the start time of A minus B dot, and this is the start time of B. So this is now sorted, and we need to return the result, which is of int. So size, where is it? Line number 16. And the Java solution is also accepted. Finally, we will do it in Python 3. So we need it after this. And here we will use just lists, no fancy stuff. and this interval is already a list, so let's remove this. So this is now sorted. Next, we have to keep the result. So whatever value you initialize it with, it does not matter. You can initialize with 0 also. So sorted is already accessible to this one. So no need to pass this, just pass x. N is also accessible. Zero, 0. Okay, so this is the main function. This is the binary search part. And the Python solution is also accepted. So if you have any other solution, then you can share in the comment section.